Okay, so I wanted to describe our very simple and somewhat shitty convolutional neural network that we designed at Chess Hacks. So it's not optimized. However, I think it helps explain the idea of the CNN very well. And we do have an optimized version. Now, the essential idea of the CNN is that we're going to take in the board as an input. We're going to output a probability distribution for each position on the board. So, what does that look like? We represent the board as a tensor being in my own words, a compressed, easy to compare version of like a vector, where we have things like the number of planes, the board width, and the board height. So these are representing the dimensions. And we output this r to the 4096. This does not equal this. We get 4096 as each space on the board has it's basically for each space on the board we find all other spaces, and we say that's a option to move. Not all of these are legal. For example, the knight is in the bottom left and it goes to the top right. That's not legal, but we'll deal with that later. We're just concerned with possibilities, and we're going to perform a softmax on them later. So once again, we get 4096 because we count every from cell to every to cell as a potential move. And this again is a tensor. What is a plane? A plane is a feature that we search for. This is not the same as a filter. A plane is just like the rules of the game. So if we have the chessboard here, and as you know, pawns start off here. The first one would be like checking for white pawns. So everything would be 0 except for this row. So there'd be these 6 types, and these 6 types as well. And you could just take these and add 6 for the block implementation. So you only need like an enum of 6. There's also stuff like castling, en passant, whose side it is to move. And yeah, so these are the planes that we check every time. We also, although this is the representation of the board, when we're actually running the neural network, we flatten it into one long vector, which is the product of these, which would be 4,200 something. And the actual CNN, what it learns, the hidden layers that it finds, are a 3x3 sliding window over the chessboard, where they find stuff like piece clusters, formations, threats, symmetry, pawn structure, checks, pins, etc. We don't set these, that's what it learns. So I'm going to show the loop in a way that I understand it. This is like gradient descent and learning rate and stuff like that. This is a little toy network that we're playing around with on paper. But what I really want to look at is this. So this is what you'll usually see in a neural network diagram. This is what my team and I came up with for how we understand things to be working. So we get our board as a tensor, and we enter the forward pass. So input the board into the CNN, outputs and logits, which are basically probability distribution but not normalized. It's like you just have a number for every position on the board. It could be above 1, etc. Then we set the illegal ones to be like to negative infinity. Then softmax sets everything between 0 and 1. Argmax does something else. We calculate the loss. How is this compared to stockfish? And then this then feeds back into edit the gradients in order to update the weights, and repeats for each position in the data set. Once we repeat for every position in the data set, we do another loop for every epoch. So you kind of see the flow going around here. Now this is the more common way of representing a neural network. So here is our input layer. This is our tensor, which is flattened to be like x1, x2, x3, x4, x5, dot dot dot, x like 800, whatever. And there's a bunch of layers in between. I believe as you scale more of these epochs and like you edit the training stuff, there's more hidden layers in between where they learn increasingly more complicated things. But each of these is a weight. So all of them connect to each other and the weights kind of learn. And this is not our problem because that's up to the AI to do. And then it comes out to an output, which I put it as this one number because it's our ideal move. But in like 3B1 Brown's video of detecting digits, there's like 10 outputs, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it depends on what you're doing for your CNN. But we compare against loss, and then we want to minimize it. So we edit the weights, and we do this over and over and over again. There's also these things, policy head and value head, that happen around here. Policy is essentially the probability distribution, and value head is like, how are you winning? Are you winning, son? Kind of thing. Like, are you winning? What is the state of the board? And so, yeah, that's everything I kind of learned over this weekend for chess hacks, and I'll give a better update in the future.